Hi, I thought I should do a video for the next module, which is module 2. Hopefully by now everything is up and running. You're in Cengage, you've got GitHub account, you have Python installed locally, and maybe you have Visual Studio Code as well. Okay, so let's have a look at data types. So what we want to be able to do is explain the difference between different numerical data types, be able to use operators on numerical data types, figure out what a string is and how string operations, indexing, slicing and formatting work, talk about escape sequences, and we can talk about lists, which is sort of like an array, and perform operations on them, and then talk about Boolean expressions and operators. So there's a few different sorts of numbers. The two main ones are integers, which are the counting numbers or the whole numbers. They can be positive or negative. They have unlimited precision. We can count up as high as we want. 1, 2, 3, just adding 1 to the previous number. And in Python, that type is indicated as int or int. And sometimes where integers or whole numbers aren't what we want, and we want a number with a decimal part. And this is the float type. And they're not the same sort of numbers as integers. So you may sometimes want to convert from, for example, an integer 7 to a floating point value 7. And you just use the float function to do that. Normally we use base 10 decimal numbers, but there are at least 3 other commonly used bases: base 2, base 16 and base 8, and they're all sort of related to each other, right? 2 times 2 times 2 is 8, and 2 times 8 is 16. So binary is base 2, and that's what computers use in all of their inner workings. And they're just not the numerals 0 and 1. And in order to put a binary number into Python, you prefix the number with 0b. And if you want to convert a decimal number to a binary number, you use the bin function. Hexadecimal is base 16. And in order to indicate that the number is hexadecimal, we use 0x as the prefix. So 0xf is the number 15, or f in hexadecimal. In order to convert a decimal number to a hexadecimal number, we use the hex function. And similarly, octal. Now this slide is wrong, obviously. Right, the 0xf is the hexadecimal number. In octal, base 8, the only numerals allowed in our number are 0, 1, 2, 3, 4, 5, 6, 7. Right, so and the way we indicate an octal number in Python is 0 small o. So an example here would be 0 small o 3, 4, for example. And to convert from a decimal number to an octal number, you use the oct function. And then when you've got numbers, you usually want to do math with them. So there's addition, subtraction, multiplication, division, and floor division. Floor division is useful if you're particularly dealing with integers, because integers don't allow decimal parts, so or numbers less than 1, so 0.5 or 0.32, and floor division ensures that the result of the division is always an integer, so the fraction is discarded. And then there's various other things. The modulus function, the absolute value, convert to an integer, we showed that before. Float, we showed that before. Div mod returns quotient and remainder of two numbers. And star star is the power or exponent function. And modulus again at the bottom. We also have assignment operators that are not just equals. So plus equals if we allows you to increment a variable by the number on the right hand side. So x plus equals 7 is equivalent to x equals x plus 7. Similarly for minus and times and divided by. And modulo also does it, as does the power function, as does the integer division function. You've probably come across this acronym before, PEMDAS, and this is the precedence of operations, the order of operations. First of all, you do anything inside parentheses, then you deal with exponents, then you deal with multiplication and division, which includes floor division and modulus, and then you do addition and subtraction. So let's just, before we go on, let's quickly have a look at some of that, right? So there's the number 7, but if I make float 7, I get 7.0, which is, I suppose, what we would expect. And then I can do something like that. So there's the order of operations, 8 times 1 plus 4. 1 plus 4 is inside parentheses. So we do that first, and then we do the multiplication. If I did 8 times 1 plus 4, that's going to give me a different answer, because now there's no parentheses, so the first thing I have to do is multiplication, and then the addition comes last. Div mod, let's see if we can go 30, 5, right? So 5 goes into 30 6 times, mod with 0 remainder. But if I made it 31, 5 goes into 31 6 times with a remainder of 1. Right, so I'm getting 2 answers out of the div mod function. And then I can do 30 modulo 5. That's the second answer I'm getting back from div mod. And 31 modulo 5 is the second answer I'm getting back from div mod for 31, 5. Okay, strings. Strings are sequences of characters. You can use single or double quote. You can use multi-line strings and use triple quotes. And that all hangs together. As we saw in one of the examples, GitHub problems, if you multiply a string by an integer, then the string repeats that number of times. And if you use the addition operation, the plus sign, that will concatenate strings, run strings together. Now, there's a statement at the bottom there that says strings are immutable. All right, so what does that mean? Let's see if we can, I can quickly, this is a string, and I'm going to assign a string to that, right? And then if I try oops, I should right, if I try and set the first element of this as a string, it says object does not support the assignment. That means I cannot change. Once I've set the string variable, I can't change it. I can make a copy of it and change the copy, but the one that I created, I cannot change, right? So for example, I'm trying to do this on the fly. I could say that, and let's go from 1 to how long is it going to be? This is a string. 1, 2, 3, 4, 5, 6, 7, 8. And then if we print another string, oops, I got the wrong number. I should have said 8. Right, so what that does is it ignores the first or the 0th element of this is a string and puts a B in its place. But I haven't changed this is a string. It's still immutable. Right, it hasn't changed what's in it. And that's what I was doing. I was indexing into the string, and I did a range of indices, right, from the start index to the end index. And there's a snippet showing what I was pretty much what I was doing previously with Python directly. There's a built-in function called len, which allows us to identify the length of the string. And there's a thing called string interpolation. That's the process of evaluating a string that has placeholders. So we call these strings F strings because they're usually prefixed with an F, meaning it's supposed to be interpreted. And the interpretation is done where the curly braces are. Right, so here is an example. Here we have an integer variable, number, and we've assigned 7 to number. And then our interpolating string has number plus 1 in curly braces, so that means that expression is going to be evaluated and replace the curly brace, open curly brace, number plus 1, close curly brace with the result. And the result is obviously going to be 8. Number 7 plus 1 is 8, and that gives us the result. We can also do something a bit more finicky using format. And that means we can insert different values in different positions and have several different arguments instead of just the one. There is another formatting called % formatting, but I suggest you ignore that. It's deprecated and will go away eventually. There's various other things you can do with strings. You can capitalize them, you can turn them into lowercase, and you can turn them all into uppercase. So let's have a quick look at that. Right, so this is a string upper, right, and then this is a string, I hope that's visible, is it? Maybe it's not. Oh, let me just raise it up a bit. There we go. Right, there we go. This is a string lower, and what was it? Capitalize. Right, that capitalized it. And then we can do starts with, ends with strip, which removes any leading and or trailing spaces, and we can replace things. Right, and remember again, we're not going to, the string is immutable, so we're not replacing things in the string. We're creating a new string with those things replaced in it, compared with the original string. Sometimes we want to represent characters that are not on the keyboard, and the usual ones for these are the bell sound, the new line symbol /n, or sometimes a single quote, and we escape those by a backslash. Right? It's possible to write a string in Python with single quotes enclosed. That means you need, if you want a single quote inside your string, you need to escape it. Right? If I do something like this is a string, right? It doesn't like it, but if I do that, it allows me to escape the string and put it in there. Okay, so we can also do lists, and they're aggregated data types. That means we can mix and match stuff in the list. They're indexed, so we can pull out the 0th, 1st, 10th item. They have a length, they have an element count. Lists are mutable, so you can change them. They all start at index 0, and they can have negative indices. Slicing is what we were doing earlier with the string. We can have a start index and an ending index. We can concatenate strings together with the plus, and to change values in the list we can use the assignment at a particular index, or we can grow the list by using the append method on the list. We also have another data type called a Boolean. This has values of either true or false, and normally these are associated with control statements, so if statements or while loops or for loops. With Booleans, we're going to get a Boolean rather when we use comparison operators like less than, greater than, not equal to, is or is not. And there are some specific logical operations, not x, x and y, x or y. Sometimes we have a list and we want to know whether something is in the list, so we use the in operator. Or if we want to know if something's not in the list, we use the not in operator. So that's about it. We had a look at data types. We talked about numerical data types, integers and floats, and then different bases, base 10, base 2, base 8, and base 16. We talked about strings, and we had a brief look at lists, but we need to go into a little bit more detail with lists later on. Okay, that's it for Module 2.